One more set of examples for solving exponential equations here with examples 5 and 6 from your Module 6.2 class notes. This time we don't have two sides that are powers of the same base, which we saw in examples 1 through 3. We also don't have two sides that are powers of different bases, like we saw in example 4. This time, we just have, and as we'll see as we work through both of these examples, we will see, we just have a single side of the equation that's exponential, and then the other side of the equation is just a number. So what do we do with, and let's see, what do we do when, let's focus on question number 5, example number 5 for now. As I try to solve for t, try to get the t by itself. What would be your first step? First thing I'm thinking of is I could divide by 3. E to the 0.5t is equal to 11/3. Now I'm trying to solve for t, and there's a problem. The t is stuck up in the power of the exponential base e. I could use logarithms, and in fact, I very well could use logarithms. That's a perfectly good approach, just like we did in example 4 in the last video. But there's another way here, a way that makes more sense to me, and I'm going to show you in these two examples what I mean. What I have here that's different from the previous examples is I've just got a single side of the equation that is an exponential. And the other side, the right-hand side here, is just a number. So I've got a base to a power equals a result. We've talked before about a base to a power equals a result. That's just our definition of a logarithm that says if I've got a base to a power equals a result, I could actually just rewrite that, rearrange that into a logarithm. Log base e, the natural log, of the result 11/3 equals the power 0.5t. So see how I just took the base e exponential and translated it to the base e natural logarithm with a result of 11/3 and a power of 0.5t. We did that all the way back in section 5.2. What was that, like 2 days ago? So very long ago. And we got some practice with converting between exponential form and logarithmic form using that definition. We're back. And now that definition is giving us a way to transform an exponential equation into a logarithmic equation that now can be solved for the variable that succeeded in getting the t out of the power, and now we can solve for t. What's the last step in solving for t here? Just multiply both sides by 2 to cancel out that 0.5. Multiply both sides by 2, and t equals 2 times the natural log of 11/3. In question number 6, we have a similar situation here, although we do have that e to the 2t terms on both sides of the equation. Still, let's just start getting the t by itself. Let's combine those two e to the 2t terms by subtracting e to the 2t on both sides. We've got 7e to the 2t, and I'm going to subtract over 1e to the 2t, leaving me with 6e to the 2t. Now let's keep trying to get t by itself. A good next step would be dividing both sides by 6. 3 over 6, that's 1/2, equals e to the 2t. Now we've got an exponential term equal to a number, and we can do the same thing we did before. We've got I'll even color it all up again, e base to a power, what did I use? Red for the power, to a power of 2t equals a result of 1/2. Swap that around, rearrange it into logarithmic form where we've got a base e natural logarithm of a result of 1/2 equals a power, that's red, of 2t. Using the definition of the logarithm to simply rearrange the exponential form to logarithmic form. Finally, we can solve for t by multiplying both sides by 1/2 to cancel out that 2 on the 2t. Multiply both sides by 1/2 and we've got t equals 1/2 times the natural log of 1/2.